The recording. Hello, I'm Professor Julio Rezende, and this presentation is about Martian soil in Brazil. Also, I will be talking about research, development, and application by Marte Space Analog Station. Okay. In this case, this is this first image is the Cabugi Volcano, extinct volcano in Brazil. In this presentation, we'll be talking about different aspects like the research goals, also first topics about survey on Mars analog soil, basalt-based on Earth. We'll be also talking about the reconnaissance of volcanic basalt deposits in the state of Rio Grande do Norte State, Brazil. Also soil analysis, methodology for soil analysis, and research on applications of Mars analog soil. We present a very interesting database developed by University of Central Florida, UCF. They have a database about different analog soils. In this case, we identified 3 experiments on simulated Mars soil and also 2 studies on moon analog soil. Okay, these 5 experiences, three from the Mars analog soil and 2 from moon analog soil. They supported the development of the research based on Brazil, in this case, the Pico do Cabugi or Cabugi Peak area. Okay, 40 minutes driving from Marte. Okay. In the next slides, we'll be presenting the Cabugi Peak, also some pages from planetary simulant database. Okay. In this case, we are located in the corner of South America, in the Rio Grande do Norte State here in Brazil. It's, as I said, around 40 minutes or 1 hour driving from Marte. This is one of the images of Cabugi Peak. Some landscape from the rocks in the Cabugi Volcano. Also, this inspired us to look to identify other areas, other analog soils based in basalt. In this case, we were identified in UCF planetary simulant database 3 analog soils, like the Korean mass simulant, also Mojave and Martian garden. In this case, the Mars soil simulant was very interesting. Identified the MMS or Mojave Mars simulant. This soil was identified in Mojave Desert, and this is also an analog soil used by JPL for the research, also related to the rover's development, in this case, Perseverance. They used the soil in the Mars Garden, one facility inside of JPL in Pasadena, California. Also, there is some papers related with this. One of the papers is some authors. The main author is the Gregory Peters. This is an important reference to us related to this research. Other analog soil, Mars analog soil, is related to the soil developed by Korea. Was developed by Hanyang University. Also was a soil collected in Hantangang River in Korea. That soil is developed by the company called Martian Garden. Also, the soil Martian Garden is available in the website of the company. Is also used to some research developed in schools, and it's possible it's available to everybody by the soil. The other 2 samples are related to moon samples. One of the samples was collected by Maryland University of Maryland, also in the Sanders Okay, and also there is some articles about and the last analog soil, moon analog soil, was called of Black Point, okay, and was developed by Kennedy Space Center, okay, and was collected from a lava flow, okay, in Arizona. In this case, also there is some references, some papers related to the moon analog soil mentioned. Okay, in this case, we this experience related to the also Mars and Moon inspired us to Habitat Marte research group developed analysis about the possible analog soil from Brazil. Okay, we identified in the literature some studies mentioned the interesting characteristics from Pico do Cabugi or Cabugi Peak here. Okay, it's in this case Cabugi Peak presents 590 meters of altitude. Okay, and we developed a methodology to collect the soil for analysis. Okay, some photos of the Souza and Sara from Brazil, and I also collecting the soil. Also, we collect some samples. These samples was transported to a center of technology, mineral center of technology, or technology center, mining technology center from the Federal Institute in Brazil, in Rio Grande, Norte State. The technicians and researchers did an analysis, considered a semi-quantitative chemical analysis using the portable X-ray fluorescence spectrometer, also other features, doing also the analysis, and also in the end releasing a technical report. In this case, we have here the results. 36% is characterized by iron oxide, also presents the silicon dioxide, calcium oxide, aluminum oxide, the titanium dioxide. And we saw some common characteristics when we are looking also the soil commented by Peters et al. In the paper of 2008 that we mentioned in the beginning of this presentation. Okay. Also, we are doing more analysis, more accurate analysis. Also preparing a paper about these characteristics of this analog soil from Brazil. Now we'll be seeing some possible applications for analog soil. In this case, we can see the 3 possible applications in the research developed by Habitat Marte. The first possibility is food cultivation on Mars and Moon. The second possibility is additive printing of items and products. And the third possibility is additive printing of habitats. These are 3 different interesting possibilities. Because in the first possibility related to food production, we have this equipment that we are preparing the soil to be cultivated inside of these kind of chambers in a confined environment, a closed loop system. Something that we would like to add is a camera to have the remote follow-up to see if the operations are occurring correctly or not. Okay, we'd like to see this chamber operating in Habitat Marte, and we are from Natal, 100 kilometers, or someone from a different country. Be possible to look how these plants are developing. Okay, in the pots. In this case, the next steps are define the kind of plant, selecting seeds, also prepare the soil, in this case, the regolith, also the cultivation, also monitor, because for monitor it's important some cameras to see the development of the plant. And the last part is harvesting, the collecting the plants to consume. One more point is very important is possible discussion related to food cultivation, because if you have success using the analogous soil, maybe this would be very useful to a lot of discussion related to possible food to cultivate on Mars and Moon. And we consider this possibility very strategic. Okay. The second possibility is the use of the knowledge soil to cultivate, also to produce some utensils, as possible see here, a kind of pot. Okay, one of the challenge to print utensils is acquire equipment to perform the additive printing process. Also, the third possibility is the printing, the 3D printing of some habitats. In this case, we have it's possible to see here an image of the MARSHA habitat. This was developed during a competition. Also, it's in this additive process, they are adding a kind of plastic PLA with also a kind of clay. This in additive process is added layer by layer here. Also, there is a kind of vent. This vent is releasing a heat ventilation here to accelerate the process of solidification, to solidify the layers. Okay. The challenge for habitat print is identify a soil deposit with legal, technical, and logistical conditions to supply the raw material in quantity and quality. Also, we consider that this for 3D printing will be demanding a lot of quantity of this material because the size of the habitat. Also, it's supposed to be presenting a very, I don't know the name, but a very regular dispersion of the particles, because we need to present a good granulometry. It's not possible for the 3D printer. We have something like a stone. In this case, we need to prepare the soil, the powder, to add water or other elements to provide the good process of solidification of the 3D printed process. According this raw material will be added layer by layer. Okay. In this case, there's a lot of methodology to be considered before the process of the 3D printer, because the substance need to be very well done, not to block the passage, the process to release the 3D printing filament. Okay. In this case, it's also necessary to develop equipment and technologies to perform the 3D printing of a habitat. In this case, we are concluding this presentation as we can see promising achievements and future research. Also, it's very important looking for partners and funding for adequate equipment and perform the experiments, and also some references. And yes, this is my presentation. Also, my last slide. Okay, thanks so much.